All right, welcome to the Explainer. So today we're going to dig into a tool that, pretty much all of us use every single day, but maybe don't really get what's going on under the hood. I'm talking about Git. And our goal here isn't just to show you more commands to memorize, it's to finally help you understand it. So let's dive in.
Does this sound familiar to you? You've memorized commit, push, pull. You've got the basics down. But the second something goes wrong, it's like your magic spells just stopped working, right? And you're frantically Googling for a fix? Look, you are not alone. That feeling is super common. Today, we're going to swap out that fear and uncertainty for some real clarity.
So here's the game plan. We're going to start with creating your first draft, then look at tracking revisions. After that, we'll get into working in parallel, merging your ideas, and finally, collaborating with your team. It's a really logical path to finally getting a solid grip on Git.
All right, section 1, creating your first draft. Going from a totally empty folder to version 1. Now to make all this stuff click, we're going to use a simple analogy. For the next few minutes, I want you to forget about code. Instead, let's pretend we're writing a book. This whole book metaphor is going to be our guide to visualizing what each Git command is really doing behind the scenes.
Okay, every single Git project starts right here with this one command. When you're in your new folder, our book folder, and you type git init, something magical happens. Git creates this hidden little .git folder. You can think of this as the project's brain. And what's so cool is that this brain is totally separate from your actual files. This is key, because it means Git can watch and track every little thing you do without messing with your work until you explicitly tell it to. So, we've written our first file. Let's call it thanks.txt. Now to let Git know that we actually care about this file and want to track it, we use git add. Now, this command doesn't actually save a new version yet. It's more like putting that file onto a list for the next official version we're about to make. You're basically telling Git, hey, pay attention to this file. Get it ready.
And this little middle step, it has a name. It's called the staging area. And honestly, it is so powerful. See, instead of having to save every single tiny change you make, the staging area lets you group related changes together. So you can, say, fix a typo in one file, add a brand new image in another, and then decide to package them together into one single, meaningful update. It's all about giving you total control over your project's history.
Right, so once you're happy with everything you've put in the staging area, you run git commit. Think of this as the final step. This command takes everything you've staged and it basically seals it in concrete. It creates a permanent snapshot of your project at that exact moment in time. The snapshot, well, that's what we call a commit. And just like that, we've made our very first official version.
So, that first commit is our foundation. Now we get to see how we build on top of that to create a full, trackable history of our book's journey. Let's track our revisions.
So as we keep working, we're building up this history, right? We add an outline file, that's a commit. We fix a typo in our thanks file, that's another commit. And you can see how it's forming this beautiful, clean, logical timeline. This is exactly why small, focused commits are a best practice. Because think about it, if we later decide that typo fix was actually a bad idea, we can undo just that one commit without messing up the outline we added earlier. It's like a superpower.
But how does Git know where the next commit is supposed to go? Well, it uses a special pointer, and it's called head, all caps. The easiest way to think about head is just like a big, glowing "You Are Here" sign on a map of your project's history. It's always pointing to the specific commit that you're currently working on. Now, right there alongside head, you'll almost always see another label. It's a branch, and by default, it's usually called main. A branch is nothing more than a simple named pointer to a specific commit. So, while head is always moving forward with every new commit you make, a branch acts like a stable, easy-to-read name for a whole line of work. And this simple idea, this is where Git truly becomes a game changer.
Okay, let's talk about working in parallel. This is how branches let you explore new ideas completely safely. The whole reason branches are so incredible is that we can have more than one. This means we can work on multiple things at the exact same time, and they won't interfere with each other at all. This might just be the single most important concept in Git, especially for teamwork and trying out new things.
And making a new branch, it's super easy. First, git branch my branch just creates a new little pointer with that name, and it points to the exact same commit that main is on.
Then you type git switch my branch, and that moves your "you are here" sign, your head pointer, over to this new branch. And that's it. You are now officially working on a separate line of development.
And this right here is the magic of branching. Our main branch can stay pristine and clean. That's the polished manuscript that's ready to go to the editor. But meanwhile, over on our new branch, my branch, we can get as messy as we want. We can write a half-finished, terrible first draft of a new chapter. We can try out some wild new idea. And none of it, absolutely none of it, puts our stable main version at risk. It's the ultimate safety net for creativity.
So let's say we make a couple of commits on our new branch. Our project's history now looks something like this. The main branch is still back at commit 3, our stable version. But my branch has moved forward to commit 5, where we're working on our new experimental chapter. And our head pointer, our "you are here" sign, is pointing to my branch. So our history has split. It's diverged into two separate timelines.
Okay, so we've done it. We finished that awesome new chapter on my branch. It's brilliant, it's perfect, so what now? How do we get that fantastic new work back into our main manuscript? Well, the answer is we merge. Let's talk about bringing these different histories back together.
Now, before we go any further, here is a huge pro tip. The safest thing to do is not to merge your branch into main right away. Instead, you switch back to your branch and you merge main into it. So you run git merge main while you're on my branch. Why would you do that? Well, this pulls any new updates from the main version into your experimental space. It lets you fix any conflicts or test for bugs right here in your own safe little sandbox before you ever touch the clean, stable main branch.
When you do this, Git creates something really special, a merge commit. And that's what this number 2 is all about. It represents the fact that a merge commit has two parents. See, a normal commit only has one parent, the one that came before it. But a merge commit is like a knot that ties two separate histories, in our case, main and my branch, back together into one. Now that our branch contains everything, we can safely merge it into main, and just like that, our new chapter is officially part of the book.
Okay, up until now, every single thing we've done has been just on our own computer, in our local repository. But let's be real, the true power of Git comes from collaboration. So, how do we share our book with, say, our publisher or a teammate? This is where we start talking about collaborating and sharing our work.
To work with other people, we need a central, shared place for our project to live. In the world of Git, we call this a remote. A remote is really just another copy of your repository that's hosted somewhere online, like on GitHub or GitLab. For our book metaphor, let's just call this remote the publisher. It's the official, central copy of our manuscript.
So, how do we get our work up to the publisher? We use the command git push. When we run git push publisher main, we're telling Git to send our local main branch to the remote we called publisher. And a few things happen here. First, it uploads all of our new commits. Second, it creates a copy of our main branch on the remote, which we can think of as publisher/main. And third, it creates a link between our local branch and that new remote branch so Git knows they belong together.
Okay, that's how we send changes. But what about getting changes from other people? Most of us just blindly type git pull, right? But here is a huge aha moment for so many people. Git pull is not actually one command. It's two commands squished together. First, it runs git fetch. That part just downloads all the latest history from the remote. It doesn't change your files yet. Then it runs git merge to actually combine that new history into your local branch. Seriously, understanding that pull is just a fetch and then a merge is a massive step to a really mastering Git.
So, let's say our editor made some changes. We pull them down, which we now know as a fetch and a merge. We've now got their changes integrated with ours. Our local main branch is now officially ahead of the publisher/main branch. It contains everything. The only thing left to do is to complete the cycle. We run one more git push publisher main, sending our fully merged history back up. And now, everyone is on the same page.
And that's really the whole loop, from init to commit, from branch to merge, and from pull to push. You now have a visual, mental model for what is actually happening under the hood. Git isn't just a bunch of commands to memorize. It's a safety net. It's a system that gives you the freedom to experiment, to collaborate, and to make big sweeping changes, always knowing you can get back to a safe version. It removes the fear. So now the only question left to ask is, now that you can build without fear, what will you create?